So who says robots aren't ready for prime time yet? Today we get a chance to meet Chris Paxton, a roboticist who's leading embodied AI at Hello Robot, whose goal is to build practical, in-home mobile robots. You can actually buy one of their stretch robots right now from their website for under $25,000. Let's see all the things these in-home robots can do just using wheels and pinchers for hands. Chris previously worked for Fair Labs at Meta and NVIDIA Research. With a PhD in computer science, his work has gotten awards at top robotics conferences like ICRA and Co-RL. His research looks at using language, perception, planning, and policy learning to make robots into general purpose assistants. Welcome, Chris. Thank you so much for joining me.
Thank you. Thanks for having me.
So, tell me more about your stretch robot. I love the philosophy you guys have taken. Get it into the home, and then, but it's so practical, it's so useful already. Just give me a little bit of a description of this stretch robot.
Yeah, so the stretch robot is it's a low-cost mobile manipulator. It's lightweight, so it's about 40 pounds. You can see it here. I think what that means is that you can carry it around. It can go into your home. It's small enough that it's about the same size as a person, so it can fit through all kinds of different areas in your house. It can it's got an arm, so it's a 6-stop mobile manipulator, which means that it can grab anything that it sees. It can pick things up. It can perform all kinds of complex manipulations, and it's basically a lightweight, low-cost robot that can go into homes and labs and any particular environment and do meaningful work for people.
Yeah. So you guys it's bootstrapped, but you've already built a bunch of robots. Is it already in the homes now? And I saw that the way you developed was really bring it. Tell me how
it's in my home. Yeah, it's in homes now. Yeah.
Great.
Yeah.
Okay. Tell me more.
So we do a lot of work with researchers. So my background, a lot of that is as a researcher, an AI researcher at a bunch of different top company labs and things like that. So the nice thing about it is that there are lots of people who work with the robot already. There's a huge community built up around it. I think you actually had a nice graphic showing all the different people who've worked with the robot. So got tons of external collaborators and partners. Yeah, this is the one. A lot of people really like it. The capabilities, because it is very capable and very lightweight, human friendly, and safe. The team did a really good job designing it before I joined to be this very safe and friendly and usable piece of hardware. Yeah. So.
Yeah, it looks fantastic. So tell us more. Is it? Are you training it to be autonomous? Is it already autonomous at this point? What tasks can it do?
So it's a good question. So it can do a lot of different stuff, and actually, it's a generalist It's a generalist robot. So it can do So it can do pretty much whatever things you can think about. So it doesn't need to be autonomous. A lot of people do use it autonomous. This, for example, is a demo of it being used in a New York apartment by some collaborators of ours from research, which I worked on, where it's able to do things like autonomously find and pick up objects and move them around in different homes. We can have the robots. We can do autonomous behaviors. Another way people do use it is just through teleoperating it. There's lots of people get used to it that way. There's a lot of different. Basically, it's a general purpose platform. It's not for robots they can do all kinds of different stuff. Yeah. So it is autonomous sometimes.
It is, and so you can use it. There is use cases for teleoperation.
There are use cases for it that are autonomous. Yes.
Yeah. So somebody's using a Zoom or something like that. I guess it's got a camera, right?
It does a camera. It's got cameras on it. It's got so you can see there's a depth sensor in the head, and there's another camera on the wrist, and so you can remotely operate it. You can write code for it. You can have it do all kinds of different. Tasks. A lot of the researchers who use it train different AI models, and so it's really, I think it's got a lot of the forefront of AI is being tested on these kinds of things. Like this kind of stuff, I think is really exciting because this is the real challenges in robotics are ones that you get to face when you have a robot like this that can go into homes. And in robotics, and not just robotics, but also AI. So a lot of the hardest things that you can have robots do involve, like, it was never trained in this particular home, right? And I showed a couple other videos, and all of them that is true for. There's no, they're not trained, and they're not trained in these homes. These are unseen environments and objects. So the thing that this is a problem that I've done a bunch of research in, called open vocabulary mobile manipulation, meaning that, like, you should be able to have a robot which can go into your home without me training data. I shouldn't need like a bunch of demonstration data on that home, and it needs to be able to manipulate and grab any object that I might ask for and be able to go and do it and take it places and be intelligent. And so to be able to do that, we need robots that you can actually, like, I can, all those things that I talked about earlier. It's friendly, it's human safe, it's not going to like hurt my dog or anything by accident if I had a dog. It's gonna be able to be, it's light enough, and it's also capable enough, so you're not sacrificing anything really when you do this.
Is it fair to say that, and I hope that it's not an insult, but like thinking of it like a Roomba. So a Roomba, people buy, it's a consumer product, it's in the home, and it does one thing, it vacuums. And it doesn't necessarily do it very well because it's not that intelligent. Yours, it's got the wheels and it can drive around, but it's got the manipulator hands. And even though it's a pincher, you guys will say, and you guys will show that it can do everything and anything. It's like almost unlimited what it can achieve with that. But then you're saying that it can actually identify project. It's intelligent. Are you coding that yourself, or do you have your own? You know what I mean? Like the other human or robot companies that we've interviewed, they have partnerships with OpenAI, and that's what they're using for visual perception, or NVIDIA's simulation environment. What's your approach? Yeah,
that's another good question. So I think part of our idea has been that we have this big community. Like, the reason that I shared that first video was because that one's actually, that's an example of a collaboration with our community of researchers and so on. So those are some researchers who, like, so I think the idea is that there are a lot of hard unsolved problems. Like, I like these kinds of videos. This is a home that was actually like in use. Well, like this is my kitchen actually. Okay. But so the kid's doing these kinds of things, and just turn on the robot and have it go and try to pick up these things and go over, take them to the sink, stuff like that. So like you can start. This is using the same method from the previous video though. So it's not like it's not been trained for this or anything like that. It's all just deployed in these different home environments, and we can. You can test it out in different locations. So our strategy for this is leveraging lots of open source, working with people, making sure that it works well. We have these strong collaborations and partners and so on. And that lets us, I think that's an exciting, and it's a very exciting way of kind of moving the field forward. Yeah.
Gotcha. Yeah. I see that you guys actually won the IEEE award for this technology. Like, it's supposed to be like the company that has the most potential for improving the quality of life. Can you the overall benefit to humankind?
Yeah. So I love that. That actually happened before I joined the company, I would say. So that's so I have nothing to do with that at all. Yeah. I think that's something that I think, but I will say that that's one of the reasons why I did, right? I love, like, the fact is that I think that personally, I think that robots like this are going to make a huge difference in people's life. The particular reason for that one was actually because there were the founders and the team, again, they had these robots, and you're able to work with people with disabilities, people who need help with people who need help, or who want to be able to do different things. And the cool thing about the robot is that people can use it. They get utility out of it. It helps them out, or they can make. I think the dream of having robots like this that can make people more independent and more able to do whatever they want to do is really exciting.
Yeah, and it seems like your approach is practical, simple. And now, is it also with all the partners, right? So it's sounding like you have this open source kind of thing where you are a platform, and then you let others use it for training, use it for research, but also use their techniques. So it doesn't matter to you. Are you guys kind of partner agnostic kind of thing?
Yeah, we do take some of this stuff back. I think like a lot of the stuff that you're showing off here, the autonomy is like slowly kind of going to be shared. But I think there's a lot of there's a huge belief in open source. there's a huge belief in open source and open community. This is the video that you're playing here is another good example of that kind of community stuff. So we ran a competition where we gave a robot as a prize, and we're just like making sure that the robots can move around and be able to do stuff like grasping and manipulation in homes. I think that this is right. So again, the idea being, can you in an unseen environment ask for any particular object to go to any particular location and have that actually happen? And these like a lot of these open questions in AI, again, are things that we explore a lot that I think they're really like, how well can we build systems that generalize and adapt and run in any environment you can think of? And to be able to do that, you need robots that you can actually like take to any place that you can imagine and run experiments. So yeah.
Okay, so you're already out there and you're already doing all this. You're already training it. That's fantastic. I'll play some more of that, but I'll add Scott Walter. He's a 2-time robotics company founder as well to the conversation. Welcome, Scott.
Yeah. Hello, Chris. Hello, Herbert.
Hi.
Yeah, so Chris, it's pretty interesting looking at the Hello Bot, and I've got a couple of questions that, and in the first video, I noticed there was some text underneath that was saying, pick up Apple box, put on the box. Is that something that the researchers were entering in as tasks, or is that something that it was sort of displaying back that this is what I'm about to do? So I wasn't quite sure whether you
yeah.
Okay, so yeah. So I wonder if there was like a high level thing of like clean up the room, and then it starts cleaning up the room, and then it's coming back and saying, "Oh, I'm going to get the Apple box now. Move it on over there." Okay, so that was like text instructions.
That's the dream, right? Yeah, that's the
right.
Yeah.
Okay, so from the standpoint of the researchers, you've got an open API that is being used to drive this thing around. Have you got to the point that, because you were saying that there were different areas, like when it came to your house, it had not seen it, but was still able to do a lot of the similar tasks. So it's already got some sort of foundation model in there where it understands the concepts of objects and manipulation and how it has to avoid different objects. Is that correct?
Yeah, in those cases, yeah, we use different foundation models part of the system to be able to do this. That's right.
And I see you have also
this is sorry.
Yeah. And there's also a library of graspable objects, so like 200 plus objects. So can you give us an idea? I mean, obviously, maybe bottles is one thing, but are some rather exotic or tricky objects in that list?
There are some, what makes an object tricky, but yes, there are some really tricky ones to find. I think that some of them are really small objects, although I will say that's not a list of 200 objects that we like. Those in that particular video, those are like, some of them are training objects, like ones that you get to see when you're learning your method, but a lot of them aren't. Like, so when you're actually testing in the real world, the point is there's not a list of graspable objects, right? There's no list of graspable objects for the real world. So you have to make that reliably, be able to make that assumption that you have not seen any of these things before and you can still grab them. And so that's what our real world videos are, all with ones that it was not trained on, right? At least the ones that I'm sharing, the ones that I shared here, right? So So that kind of thing, I think, that takes us much closer to things like being able to deploy robots into real homes. It means that I can do something like unpack the robot in my kitchen and run it, and maybe it'll run slowly or whatever, but it will be able to try to do some different tasks, grabbing things. But you asked about which objects are trickier. There's a lot of like objects that you care a lot about are like, there's a bunch of different things that make objects tricky in homes. There's things like being able to find them in the first place, like small objects. Like I think there's things like finding your keys. Like that's probably like the one of those things that you'd really want your robot to be able to do. And that's always a tricky problem because keys are small, and I need to get very close to everything to be able to see whether or not I can actually detect them. There's one object that we use a lot in our demos from the simulation, which is like a multi-port USB hub, which of course is like a little black brick that's very small and has a cable coming out of it, which is just an absurd object to try to like find in a home, as I'm sure anyone who's actually tried to find a missing cable is familiar with. Yeah.
Okay. How about an object like a raw egg? Is that on the list?
No, it's not. That raw egg.
Okay. That's true. Hard boiled maybe, but yeah, the raw eggs are a little bit tricky.
Chris,
does it have? I'm sure it could grab. The robot could definitely grab those objects if it can find them. Like I think that it's more. Haven't tried that one. Yeah.
Yeah, because the egg, grabbing an egg is usually the toughest problem in robotics because you just too much force, poof, it breaks. So I was going to imagine that if you're staying away from that, there's a lot of other objects, like you say, small objects you're trying to pick up. What about like utensils? So if you could right now, could it unload the dishwasher and then put them into drawers?
That's like the AI side for that. Something we're still that's a bit
Okay.
away. Hopefully,
Okay, but physically it should be able to do something like that. So it would be able to go
the
up and pick.
hardware can.
Yep.
Yes.
Okay.
So the gripper is actually really nice and compliant. I actually think I haven't tried it. Maybe I'll go try it afterwards to see if it can pick up a raw egg. I gotta do it over the trash.
So start with hard boiled. Okay, start with hard boiled, and then move up to there.
We'll see. Yeah, I haven't tried that. Yeah.
Yeah. Or at least when you do it over a dish and make an omelet out of it.
Yeah. Do it over
Does
the
it have
trash can.
memory? So like if it's moving around my living room, it remembers things, and then when I say, "Oh, do you remember where I left my keys?" It might have remembered that that's where it last saw it.
I think in the future, yes, hopefully, yeah, that's the working in progress there. So,
Okay.
I think so. Remember, this is part of the advantage of it being like this community-powered effort, right? Like, there's a lot of researchers who are doing that kind of work with these kinds of platforms.
Gotcha.
Hopefully, that all makes these things better. It really makes all of robotics better, but especially like because this is the one that can actually go in homes. It's all very, I think, great.
Okay, so I've noticed that with the arm, so you said it's a 6 degree of freedom arm. Is that 6 degree of freedom including the vertical axis, or is that a separate degree of freedom?
It includes the base and the arm. So it's a 6-off robot, 6-off manipulator, not 6-off arm, actually. So meaning that the robot can move and it can move the arm out, meaning that.
Okay, so you have like a 3 degree freedom wrist, and then you like the elbow that's going to be able to extend out, and then you're able to go up and down in the Z, and then use the platform to rotate it around. Oh, okay, okay, yeah. Yeah, so you don't have any redundancy there. That's what I was kind of wondering. Is like, well, you could either put an additional axis up there to do that, or you could just use the base to move it. And so using the base for that axis. Okay. And that simplifies everything. Yeah, minimizes the amount of hardware you need to have.
Yeah. I think that was the idea when they designed the thing. It's like everything has to be it's supposed to be designed to be very minimal. Like it's the simple robot, right? Simply useful robots, right? That's the yeah.
So this is stretch 3. Is there like when do you guys get to? I mean, you are selling it now too, though. So is it design locked, or is there improvements that your guys going to keep adding to it? Or can you replace the hands?
So you can replace the hands on the current robot. Like it's very detachable and upgradable. We've done things like if you follow, there's people who swapped a gripper out, particularly for things like there's this UMI gripper from Stanford. I don't know if this means anything but yeah. So there's a lot of people, so you can do that kind of iteration. We continue to iterate on the platform.
And then your research, you're the embodied AI. Tell us more about what you're working on now.
Yeah, so I'm working on autonomy. So embodied AI is like intelligence and autonomy AI in the form of in a physical embodiment that can go out in the real world. So robots are one version of that, but also like AR, VR. There's a lot of different cases for this, but in particular, like what I look at is how we can make the robot more autonomous. So I just joined, right? I joined very recently, and so looking forward. We're doing these things that I mentioned here. So making sure that we have generalizable intelligence, meaning that robots work in various homes, that people have tools to build on this, and that like we can, like all these people stay happy, and that we can make the robot more useful and intelligent, all those things.
Is there a specific use case that you're going to focus on first? Or like you just been saying, that there's all these partners, they'll create different kinds of a marketplace of skills, or is there a very specific use case that you guys want to be able to say, hey, this thing can do this right now?
Right. So from my side, on the autonomy side, I think doing general tasks in the home, so manipulation, moving things around, cleaning up, that's the kind of stuff that I'm excited about. When it comes to the company direction, there's few use cases in mind, but it's supposed to be, but the idea is that it's a generalist robot. It should not be for a specific task, right? It's supposed to be able to do a wide range of different things.
Yeah. Yeah. And so, but the gripper as well, right? So, but you said you can switch it out. But you're saying too that the gripper by itself can already do so many things. But is there a plan to actually have 5 fingers?
Probably not. No,
Not needed.
but I think I think a 2-finger gripper like this is very capable. It's like you can do quite a lot with it. Actually, I think that and everything like that comes with trade-offs in terms of like difficulty to program and use and hardware and all this kind of stuff, right? Like the current gripper is very, very like these kinds of grippers are very nice for being able to do a wide range of tasks in home, like picking things up, moving objects around, all that kind of manipulation. Yeah.
Scott and I did a show on Aloha, which is these 3 PhDs in Stanford, and they showed something similar, but yours is a lot more sophisticated. But they said that if you can do a task 50 times, just 50 times, it's about 85% autonomous at that point. It can actually replicate it. What are you guys finding for yours?
I think that's a nice benchmark, but I think what often gets lost in this is that's 50 times in one environment usually, right? And so like that's where things get tricky, because like if I train my robot to like pick up an egg 50 times, that does not mean it will work in your home, right? That doesn't mean not even 85% of the time, right? So this is why we end up seeing. It's an important thing to keep in mind. And yeah, those robots are actually a great example, just to go back to the gripper thing. Those are also just using a simple 2-finger gripper, right? Yeah. You can do a ton of stuff with just 2 fingers. Yeah. And
and I also remember that Aloha, they coordinated 2 robots together to do something like trying to fold sheets. Have you considered that as well?
Yeah, actually, there's a bunch of videos on the website of which maybe can be added in post of one of the founders operating 2 robots, 2 stretch robots, and you can have them in your house, and you can move them around and put them on different sides of a kitchen island even, and do things like unload a dishwasher and put things away. So yeah, it's a great thing to do actually.
Yeah. Now, Aloha was doing a lot of their training in the real world through teleoperation. Are you training it also using teleoperation and using a lot of simulation?
We're not using so much simulation anymore, but it's mostly teleoperation. And but there's a lot of different, again, like people use different strategies. Like there's sometimes simulation is the right strategy. Sometimes using foundation models is enough. There's all kinds of things that you can do. There's no one solution when you're trying to have the robot do everything. I don't know. Right?
Do you have plans for different form factors?
I don't think no, I don't think so. That's probably not going to go into too much detail on future plans yet.
Gotcha.
But,
understood.
Yeah.
Understood.
Yeah, that's it.
Sorry. Yeah. No problem. And then the home. Why do you guys, you chose the home first? That instead of like a factory, most companies are going that factory. The only one that Scott and I interviewed who's going direct to home is 1X. And they, Bert Bornich, we did an interview with him. And he talked about all the different nuances of being in the home, right? And that's same thing what you said at the beginning. It's got to be lightweight. You got to be super careful. You don't hurt anybody. Yeah. And sometimes the simpler, the better. And that's the approach you're doing. But tell us more about the home versus factory.
So I think that from my point of view, the home is where all the exciting stuff is happening on the AI side, right? Like all the exciting challenges about like, can we build things that are generally useful and intelligent and smart, all of that stuff, like have a really wide range of environments. You need to be able to understand, able to understand very diverse scenes. You need to be able to work alongside people. All like, there's so many exciting problems to look at there. On the company side, I feel like there's like a real need for this. People want robots like this that can help them out. And there are like, that's again, I think that there's the Robots for Humanity award that the company won. And I won't say I won because that was again before I joined, right? But because they did really good work. They do all this really good work. And like, I think that part of that is because the reason that they won that is because like this genuinely can help people. And that's, I think, really exciting.
It's not meant to touch a person, right? Elderly care and actually carry them or hold them or make them stable or things like that, or is it?
I think there's some interest in this, some some research, but mostly no. Like there's some research that people have done with like using the robot for rehab, like particularly for like guiding people through exercises and stuff like that. But it's not really like mostly not for like touching people. It is fairly light, right? Like it's designed. It's like it's a as it is a very lightweight robot. But like you probably don't want to like fall on it or something like that. It'll fall over, right? It's a
Okay, so its main task is probably to help around the house by moving objects around that the individual is not able to do. What's the most sophisticated task that you've been able to accomplish at this point?
there's a lot of a lot of the research that we've seen on this is like stuff like moving things around. It's rearrangement, moving objects around in homes. There's a lot of work on. It really depends on how you want to quantify this. When it comes to the AI side, I would say it's these rearrangement tasks, like moving things around. Yeah, I think there's a whole set of like shared autonomy research that people do on this, which I think is very valuable and has its own kind of challenges, but probably not the.
So in the future, would you see it being able to do cleaning tasks or anything like that, or for the most part, just rearrangement?
I would see it being able to do cleaning tasks. I think there's a lot of cool with teleoperation. There's a lot of really cool stuff like unloading, right? So I see anything that we can teleoperate. I think we're going to be able to do autonomously eventually. So there's things like unloading clothes from a dryer, putting things in a washing machine, cleaning up, putting things away, right? All of those kinds of tasks are in scope.
Okay, and also I believe, is it plug-in power right now, or is it battery?
Battery, yeah. It's not.
Is battery okay? Because I noticed in the apartment in New York, it seemed like there was a cable attached to it. Was that a recharging cable, or was it? That was an older version.
This is the advantage of this is the thing with having like the students left it plugged in. I think that's a researcher.
Oh, okay. Because I was going to say, it's like you get a base, you should be able to put
all the other videos. It's not plugged in. It's just that one time. Yeah.
Just that one. Just so we were kind of clear about that, because I wanted to make sure. And what is the battery life?
It's all driving around totally autonomously. Yeah, like no cables plugged in, nothing like that. Yeah, this is another example in a home environment of it doing some kind of pick and place task. Yeah. Anyway, so
how do you interact with it? Can you use your voice now? Like you were saying, pick up the plush and they'll know and they'll do it. Put it away.
Yeah, you can send it. You can send it commands. There's microphones in the robot, so you should be able to talk to it. I won't say that right now that's like a feature you can download if you have a robot, but like that's talk to it. It can in these cases it's language commands for like which objects to grab. So typing, text. There's all kinds of tools for remotely operating it and through web browsers, lots of different capabilities.
So I see here there's like a 2x speed increase. A debate that I've been having with a few people is how hard is it to actually increase the speed? So almost every bot demo we've ever seen, including Tesla's, the bots still move slowly. But when we ask them, they'll say, well, we haven't decided to increase the speed. We're still working on the basics, right? The bot movement, the bot recognition, perception, being able to do things autonomously. Some people have said, if we decide to make it move faster, we can make it move faster. That won't be the difficult part. Where do you stand on that debate? How hard would it be to finally make this thing move much, much faster than it is?
So I will say it does move much, much faster than this, right? Like already. Yeah. Like that's definitely true. These videos are not from a while ago. So I do think that there are upper limits to how fast things end up moving, because like the limiting factors for all robot autonomy is like AI and perception, right? That's the tricky part, right? And that's where things tend to be difficult. And also safety, right? It can't move too fast, because if it's in a home environment, right? Like there are going to be like dogs or kids and pets and all kinds of things. There's obstacles. Things might run in front of the robot at any time. So like it should go fast. It does go faster than this now. It's not going to be blazingly fast, right? Because it just shouldn't be, right?
but it will go faster,
Yeah.
and that won't be that hard.
It does. Yes, it's much faster.
Yeah.
Yes.
Do you have to have a skills marketplace, or like if I have your robot and I taught it how to pick up the beer from my whatever, take out the cap. It's a beer. I need you to remove the cap. Is that something that if Scott buys the robot, he'll be able to have already, or does it have to be a skills marketplace that he downloads, or how does that work?
I think if you teach something, I think you would have to if you teach it something, then you could download it onto his robot. That would be the goal, I would hope. Yeah.
Yeah. As far as object perception, because you're talking about picking up different objects, how many of them does it sort of already know, and how much do you have to teach that might be custom in your house? So, my house may have like lots of pillows in there. So would it recognize pillows right away? Or if I talked about stuffed animals, and if I tell it the green pillow versus the red pillow, it would figure that out. But I might have some uniquely shaped objects. Would I be able to teach it and put a label on it so the next time I could just refer to it by name?
Yeah, that's a good question. I feel like
Yeah, so if I have like a Kermit the Frog, a stuffed animal or something like that, it hasn't seen that before. Maybe it knows it's a stuffed animal, maybe not. And I say, okay, go get me Kermit, and then it would know to get it after that.
Right. Yeah. Some parts of these, I feel like one of the advantages of the current approach being based on these like foundation models, which are all web scale, pre-trained on all these images, is a lot of stuff like that probably can just get, like, it understands a lot of these things already. Like if you ask for Kermit, something like a Kermit the Frog shaped plushie, right? That kind of thing. Like the cactus plushie there that the robot was picking up is a pretty weird object, I would say. Like, I think that there are very few children who've ever wanted like a cactus succulent, like plush stuffed animal. So I think it's appeared in Target for like once and then went out and then never again. And so I like using it as a test object because I've never seen it any other time. But and of course, the description for that was something like go and pick up the stuffed cactus, and it's like, oh yeah, goes and grabs it, right? So that's
What is the thing that you're working on that is the most difficult challenge right now? Is it perception, understanding? Is it the autonomy part? Where are you at?
I think that the difficulty with these things is always doing all of them together, right? Like it's like, how do we make sure that perception and autonomy and like each one feeds into the other, right? Because like if I need to be able to understand what I'm seeing, like where should I go next? Did I get to the right location? Does it understand what it can see? Like bringing all these things together is what will make generalist home robots useful, right? It's not like we just see things when we interact with the world. What I see influences what I do next, which influences what I see, right? So. Okay,
and then a question I ask every robot company is how many do you need to get out there before you can actually do, to scale? Some people say, you need 1,000. Let's say if the first company, if you split your company into two, you'd clone you, and one of you guys does 1,000 robots, gets it out there in the real world, is that going to succeed faster than the other one who doesn't get to the 1,000 first?
Yeah, that's a good question. I think that, like, again, the robots are already out helping people. Right. I think that there's a point where there are two separate questions: is whether there's scaling AI, which I think requires a lot of robots, but and then there's like whether or not building something useful, which I think is a very different story, right? But yeah, I think 1,000 robots seems pretty safe. So I don't know.
Right, that's the right number, right? First, try to get 1,000 robots out. No, but that's what you guys have done. You guys have kind of led as fast as you can, get into home, get there now, being tested by all these partners. That list is just pretty impressive. All these people that you guys have partnered with, and they're all, helping you or using the tool too, right? So
using the robots,
How many robots do you guys have now?
Don't know the answer to that one, or I'm not gonna give the answer. Sorry. It's
gotcha. Yep.
Yeah.
That's fair.
Yeah. But good number of robots.
Yeah. Now I have my favorite two questions. Not sure if this is going to be fair to ask, but I'll go ahead and ask it. If you could add one more degree of freedom to the robot, where would you add it?
That's a good one. I do feel like I do feel like giving it an extra degree of freedom, and that, like, because it's so tight, like if you could add the sixth degree of freedom without the robot moving, that'd be pretty nice. But I don't know. It's the
Okay, for the rotation of the base.
How high does it reach?
not
How high
the
is
yeah.
it?
How high does it reach? It reaches up to, it's about, I don't know, this high. It's a good question. It's a bit, it's like a meter and a half, almost, yeah.
Okay, because it looked like it might be close to 5 feet or something like that. It's able to get probably
Yeah.
4.5 to 5 feet.
Yeah,
So
it's about
it can
4.5 to 5
get
feet.
most things above a counter and everything like that, but not high up in the countertop. And it looks like you have 2 cameras. You have sort of a camera that's based on in the center, which I assume that's a 360 view. And you said there's also one on the hand.
Yeah, the head camera, the head can pan and tilt actually. So it's, yeah.
Oh, okay.
But
So there's sort of a degree of freedom there. Now, if you had to remove a degree of freedom, which one would that be? So those are the 2 questions to ask. You can add a joint, you can remove a joint. Which one do you take out?
Yeah. I think the robot is really nicely designed right now to be basically the exact minimum number of degrees of freedom.
Yeah, I know.
So it's very hard. It's a very hard question to answer.
And you're not the only one to sort of say pass on that one, because again, you realize that if you've really optimized it, you've thought that problem through, and you're not just throwing in a degree of freedom that is a useless degree of freedom. Okay, so that's an acceptable answer. Don't worry.
Okay, good. Yeah. I mean, the base one as well, for the one that I would add, I think it's good. The cost of adding that is not worth doing it, in my opinion. Like,
yeah, usually I preface the question that it's completely free. It costs you absolutely nothing. It adds no mass. There's absolutely no penalty. It's a magic a manipulator, a magic actuator that you could just pop in there. So
it's a fun question. Yeah, that's a good question.
Yeah.
So,
I just I'm just finishing reading for the second time a biography on Johnny Ive of Apple. And the simplest thing, removing the parts, make it as simple as possible, is actually the most difficult thing. And so, your bot looks so simple, but people don't realize that, it's designed the less parts, the less cost, the less harm to people, and yet it's maximized its capabilities of doing the useful tasks. And, people go, oh, I want to see all the beautiful, beautiful robots out there, steel outer helmets and things like that, and might not need it to get a lot done. And that's why simplicity matters.
It's the absolute definition of optimization at that point, of reducing the parts and still being able to get the functionality. And it comes right down to 6 degrees. You can't go below 6 degrees of freedom unless you want to only operate in a plane. If you want to operate in the real world, be able to pick up any object in any orientation, that's it. And then the clever thing is that, well, we need mobility too, but you don't realize that with mobility, it also gives you the degrees of freedom that you can take out. So most traditional industrial robots, when they add that kind of mobility in there, they're adding a 7th or 8th or 9th degree of freedom to it, as opposed to just saying, well, wait a minute, can't we somehow figure out how to bring the 2 together? So it's impressive to see that you've done that reduction of the degrees of freedom as much as possible, and then seeing how much utility you can actually get out of it. Because it's a very easy thought exercise to go through that, but it's something else to actually implement it and see, well, does that solution actually work in the real world?
Yeah, I think it's exciting to see, because I feel like this is doing that kind of like minimal robot. I feel like one thing that always is inspiring is robots like the Roomba, right? Like that is a robot that I'm sure all of us have in our house, a robot like that. And it really is just like the minimal amount of robot that you can have to be useful, right? Like, and I think that's nice.
So let's go back to that, because the Roomba had so much promise, and it was supposed to be very smart, and it just never got there. And then there's this whole group of robots called AMRs that I've been learning about, that Scott has lived his life working on, autonomous mobile robots. So they've been around for decades. Yeah. What's the explosion now? What is it that AI that can be done now that wasn't done with AMRs before, that really just blew things up and made this, this thing now, what your company, what you're doing, so different than the existing AMRs that's been out there?
Yeah, I think that one thing that's different is that so industrial AMRs are big and heavy. Like you cannot put one of them in your house for the most part. So I think that there's just a difference in terms of like what we can build now like supply chains and so on, all of this, right? Robots are cheaper. You can build low cost robots. Also, you can make them smart enough to be useful. Like AMRs generally, even if the hardware was exactly the same, like the one thing that drives up costs on industrial robots is always that they're very high precision. They need to get to exact positions and so on, right? Like all of that drives up the cost. You've got very expensive sensors. You've got everything is very carefully calibrated and everything everything has to be extremely precise. Like the motors in the robots are expensive. The robots are expensive. The arms are expensive. Everything about it, and that also makes them. And they're also heavy, right? They're tough. They're all of these kinds of things. That every single one of those things those which are necessary to make the industrial AMRs work, do not apply to homes, right? Like you cannot build and sell a robot like this. If you did, it would be hundreds of thousands of dollars. No one would use it. And then secondly, beforehand, even if you put that $100,000 robot, even if it was magically free, it would still not be able to do anything, because without like modern AI, without like foundation models and web scale trained models to be able to give robots common sense and some idea of how they are perceiving the world so they can interact with things, then you would not be able to do this. So that's just so many things have changed. Room's a whole different story, though. That's a
grr.
Don't get me started on the Roomba. Technically, it's not a robot.
Sure.
No. Technically, it's not a robot. Because if you look at the RIA definition, it has to have at least 6 degrees or 3 degrees of freedom, and it doesn't. It really only has 2.
Oh, I didn't know this. A robot's defined as number of degrees of freedom?
Yeah, for the standpoint of, and a certain amount of, it also has to be able to do more than one task. The ability to be able to do more than one thing, a number of degrees of freedom. So, but that's the RIA, which is the Robust Industry Association, and they have these strict definitions. And some people might say that that's more like an industrial robots consortium that you have there. And the Roomba was a little bit ahead of its time. You didn't have the best battery technology at that point, so it was like more all battery and nothing else. So it didn't have enough room to actually put in the vacuum and the motors and everything. So the part that's actually supposed to do the work, it's a vacuum cleaner, right? Seemed to be pretty small compared to everything else. So there was definitely a lot of challenges there. It's not. I don't think it's the right form factor either for being able to. But that's a different topic. You can go way down there.
Yeah. It's interesting. I was using Roomba for the genre of robot vacuums, not for the like.
Yeah. And it's a curiosity more than anything else, but I've been famous to kind of go off on a tangent whenever anyone brings up the Roomba as being a robot, and so it's like don't ever mention that around me. Never bring it up again. No.
Can Stretch be used for surveillance? It's got the video cameras, and is that not really an interest of you guys? It's not going to be one of the use cases.
It's not an interest, but you could. I mean, it's an open development platform. If you can do whatever you want with it. I think that's.
So let me get. Yeah, I think I jumped right through that. It's an open development platform, and so you guys are not. It's not closed, which means you didn't keep it private. Proprietary. You are letting developers take what you've built and build off of it, and so maybe that could be a huge competitive advantage for you, right? It becomes the standard, and everybody starts building on it.
I think so. I think this is one thing that is very exciting is all the people are building on it. I think that is a big draw. So when it comes to applications like that may not be something that I'm excited about, or might not be a feature, but someone could use it. Yeah.
Gotcha. Okay. And so that's really your goal, is to get as many of them built, get a scale, right? As scale, kept the cost low, keep it open platform, have as many people build. And so what's your specific role in the company? You're building your own AI autonomous, or is it something that you're very specific tasks you're working on, or what do you?
So I am on I am doing AI or embodied AI for the company. So part of this is making sure that we have like the tools and capabilities and models so that people can, so that we can collect data, and so that like basic functionality is there. So one thing is that, like, for example, if you want to program your robot using ChatGPT, it needs to have capabilities that so that it can go and do stuff. You need to be able to collect data well. You need to be able to train models. Those models that are trained, people should be able to use them for their own applications. So there's all kinds of stuff like this that go into making it so that it, like, basically making it developer friendly for people who want to use AI, right? That's the
love it. Okay. So Scott and I, we raise our hands if you guys want to do a beta test. Right, Scott?
Yep.
Raise hands. We always raise hands. So
Right.
if anytime you guys want to do a beta tester, we're good. We're good. We're good.
Awesome.
Guinea pigs. I'm the better guinea pig because I'm like a consumer. Scott's like, he comes with baggage.
I'll break it. Yeah.
He'll just take it apart. Is what he'll do.
Yeah. No, I see some possible use case. I mean, you talked about like surveillance being one of the things. If it's just home and if you got a connection to a mobile app and you're concerned about something that, oh, I'm getting some alarm that something's wrong, you can then tell the robot to go into a particular room or something like that and look around there and tell me if there's something missing or if something's gone wrong in there. Or again, like, oh, I think I left something at home. Go around and search for it, see if it's there.
So
or
I'm on vacation.
You heard a noise or something like that. Yeah, I mean, why not?
I'm on vacation. I go in through the web and I access this and I can see around the house. I can do things around the house. If I forgot to turn on the stove, I can go there and I can actually turn it off.
Yes. Did I leave the window open or something like that?
Can I press the garage door? I go, oh my God, I left the garage door open.
Oh yeah.
Yeah, we've actually had people like use the robots at home and like taking in packages or like or checking the mail at least, or like feeding the cats when you're on vacation, things like that.
Play with the dog while you're on vacation. Yeah. Okay, you're throwing a ball.
Yeah,
well, how do animals react to this thing? I mean, they don't, right? They don't. Because
if it feeds them, they don't care.
Obviously, again, back to the whole making it very simple, but lots of like 1X, right? Their Neo and their Eve, they purposely wanted to make it, what's the right word, Scott? Like something that humans like, easily feel like they want to be around. What's the word? It's not amorphous.
Yeah, just friendly. Yeah.
Friendly bot. Yours, utilitarian. It's a stick. It's very utilitarian. It's a clothesline. Doesn't matter.
I think that you can make something like that very friendly, and I think you can actually do it easier than a humanoid a lot of the times, because like I think that you can, if a lot of this is like adding gestures and making it behave nicely, and it can make sounds, and like, so I think that there's plenty of ways to make a robot like this friendly without it being human. Like one great example, like you can argue how useful it is. It's not very useful, but Amazon's Astro is a very friendly little robot, like lots of little emotes and gestures and things like that. And it looks nothing like a human or a dog or any of that. So I think I'm pretty optimistic on that front. I do think it's important though. It's really important for it to be friendly and likable, as much as utilitarian as well.
Okay, that would be fun. Yeah. I will beta test that for you.
No, that's good.
That's funny. This is good. Okay, so you guys are, one of the leaders. You're out there. You've taken a different approach. You're going for the home, making it scale. You've partnered with quite a number of partners out there, and you're selling it now. You can go to their website, and it's available for $24,950. It is still developer friendly, so that it's primarily developers and researchers. Do you think, or can?
Yeah, it's developers and researchers these days, especially researchers. So like, there's other users, but that's the predominant one for now.
Right. Okay. And it's moving really fast. So we'll catch up with you again next time as the skill sets get better, the marketplace gets built, the memory and the friendliness. That's what I want to see, what you do. Do people give these things names? They call it Stretch.
They call it Stretch. Yeah, it's got a name.
It's got its name. That's funny. Okay, thanks. And Scott, do you have a last question?
No, I'm fine. I want to thank Chris for taking the time. It was enlightening. I learned quite a bit.
Thanks. A lot of fun. Thank you, guys.
Thank you, Chris. So Chris works for Hello Robot, and this is, you can find him on our X at Chris_J_Paxton. I'll leave the information in the description. Thank you for your time, Chris. Appreciate you.
Thanks.
I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.